So I'm here with Doug Schneider, founder of the Soundstage network. If you haven't checked it out and you like reviews of audio equipment, industry news, show reports, they do a fantastic job of it. I wanted to ask Doug a question that's near and dear to our hearts at Axiom, which is loudspeaker measurements. Now, many reviewers and magazines these days don't measure loudspeakers at all. And those that do, I can't think of a single one that actually measures in a calibrated anechoic chamber, which is, the best place and really the only place you should, criticize or, determine the performance measurements of a loudspeaker. So I'd like to get a little bit of the history. When you started Soundstage, why did you decide, hey, I'm going to be one of those few guys that's going to, or a few companies that's going to actually measure loudspeakers? And then why did you decide you were going to do them at the NRC or the National Research Council and measure them in a real chamber?
Okay. The point about measurement is this. A lot of magazines, there could be reasons they don't measure, but I don't buy the argument that measurements don't matter. They matter in myriad ways. And one of the most basic ways they matter is what one manufacturer called keeping the manufacturers honest. Forgetting about sound, if a manufacturer says it doesn't relate to speaker measurements, but amplifier measurements, if manufacturer says the amp outputs 200 watts per channel into 8 ohms, you want to verify that because some manufacturers don't tell the truth. And it can be deceiving. And if everybody stops measuring things, then you don't have that third party.
Right. It's like checks and balances for the manufacturers.
From a most basic point of view. And when it comes to loudspeakers, sensitivity,
right,
impedance, which is important if the amplifier can drive it, that are all just basic measurements that don't necessarily tell you anything about how it'll sound, but will it be compatible? Will it work with my system? Just from a basic point of view. But then there's the sound part correlating the things. So Soundstage started in 1995, and I live in Ottawa, Canada, and that's where National Research Council is. So I always knew the importance of measurements, and I would say that one of the main reasons that most magazines don't do measurements today, they can make up stories about measurements don't matter, but it takes time, effort, and money to do it. And and knowledge, you got to know what you're doing, right, to do proper measurements. And if you don't know what you're doing, if you don't have the money, if you don't have any of that, then you're not going to do it and you're going to make up some story. Why? But the truth is the measurement should be done just as an additional piece of information.
Right.
So Soundstage started in 1995. I used to be in the computer industry and kind of got an online thing going. And in 1990, so I'm in Ottawa, Canada, as I said. So in 1999, I phoned up Paul Barton of PSP Speakers and I said, I want to do an interview with you because, one of the legends of the audio industry as a whole, and particularly in Canada. And he said, sure, I'll be at NRC. And so in 1999, I met him at NRC and we had a long talk. It went for about 4 or 5 hours. And in that talk, not only did I interview him, he explained a lot of things about loudspeaker design that I hadn't realized, a lot of what goes into designing a speaker, all the considerations you want to see. And then he said, why don't you measure speakers? And I said, I would, but it's hard to get it done. It wasn't a money issue. How would I get it done? And he said, well, I could introduce you to people at NRC. And I was like, really? And he said, yeah, let me take you over right now and we'll meet the guys who run the chamber. Mm-hmm. And so Rene St. Denis was there and his boss at the time, I can't remember who that is. And I said, hey, I live near here, run this thing called Soundstage. Paul Rentz, would you guys be interested in measuring our speakers? And they're like, sure, send us in a proposal. And I did that week. And later, about a week later, they phoned me in for kind of an interview saying, what do you plan to do? How do you present the measurements? What would you like us to do? And it was all formulated then.
Right.
So in 1999, it was really that start. We had a contract with NRC to start bringing in speakers for them to measure.
Right. And do you have to bring them personally to the NRC? Can you ship them there? I'm just wondering, in addition to the fact that, and by the way, just because it's a government agency and Doug's a Canadian, it doesn't come free.
No,
so
and that's a myth.
You have to rent it, right?
It's a myth. A few people say, oh, you get to use that NRC chamber for free. And I'm like, it isn't free. It's not as expensive as it possibly could be if you just went to, but it costs a lot of money.
Right.
It costs every batch of speakers we measure costs thousands of dollars to do the whole batch. And in the early days with Renee there, and one of the advantages of using NRC was they had a set measurement process already. In other words, they had a set way of doing measurements that people respected, people like other companies like Axiom, whatnot. It was built around in the Floyd Toole days.
Right.
And I should say that NRC, at that time when we started measuring speakers, Dr. Toole had left already to Harman, but they had established that protocol. And they also had a reference. In other words, speakers that they had measured. So in that way, the chamber and the microphone could always be checked against it to say, is it operating correctly? You got a baseline. So when we started there, what happened was they had that in place. Literally, I could ship the speakers directly there, and a couple times we did, but I would just get them shipped to me and then drop them off.
Right.
And then Renee St. Denis at the time, who was the technical person doing it, would measure the speakers entirely, often without me there. And I didn't know much about speaker measurements then, and it wasn't that much to know into about where do you put the microphone and that sort of thing, but he had it pretty set up. Over the years, though, I started getting more involved with the measurements. And we always wanted to keep it at arm's length in the sense that NRC does the measurements, but I would often be there after a while. And I would learn and I would look at things being measured and I would say, oh, let's try this, let's try that. Put the microphone here, there. There's not much variation. It's a set thing.
Right.
And so what inevitably happened, and now Randy Hartwig took Renee's position after Renee retired, is we'll just go together in the lab. And Randy will still do the bulk of the measurements, but I'll be there for the entire time, helping it out, seeing how it's being measured, what it is. We'll make sure we document everything, where the microphone's aimed on the speaker, that sort of thing.
Right. And, I have to, it's a great story, and hearing, Paul Barton brought up, Axiom, Ian Calhoun, our president, was part of that research, the original research with Floyd Toole. And it's not just the facility itself, it's the fact that you guys are using a chamber. And I think many viewers don't realize this, and it's something that we kind of harp on because we made the investment, we because Axiom has their own chamber, which is essentially the same chamber size built by the same company as the one at the NRC. That most loudspeaker manufacturers, I won't say all, a number of them do, particularly in Europe, or they have access to chambers, but most loudspeaker manufacturers don't have anechoic chambers. And so you've got a leg up now on a lot of the manufacturers to be able to do suites of measurements. Now, what I find curious about that or interesting, have you ever encountered, without naming names, a company that's come back and your measurements have shown up a flaw or something in the loudspeaker that they had no idea because they couldn't measure it?
That's happened a lot. And I would say there's a number of companies who do, we'll go back to the measurements in a chamber. If you don't have a well-known facility and a well-known process and something to calibrate, one thing is, and I see this today and I think it's dangerous online, particularly, maybe a couple magazines. If you're just measuring in a living room or your backyard or something like that, you may get a measurement out, but you may not really have a clue if it's correct. Okay, you have nothing to base it on. So that's an advantage of not just having the chamber, but a well-known process, something to benchmark. Hey, we've got something that looks right. And you're right. I would say most companies don't have a facility like that. They may or may not. Some do. Axiom, of course, does, and a handful of others. Now, there are a couple companies where they don't have a facility like that, but they understand the measurements and they can pull something like that out. But on the other hand, I would say, it's hard to put a number on it, but I would say a good 30-40% are surprised by what came out of the chamber.
Wow.
And I know for a fact, without naming names, one of the things we do, and it's we just do a THD distortion test, which I don't think any other magazine publishes.
No, because, and sorry, I'll interrupt for one moment. To do THD, to do any distortion on loudspeakers properly, you can't have any influence from a room. It's not like where you can do a quasi-anechoic measurement by gating things and taking the room reflections out with computer software.
No.
Distortion, you have to have a chamber. It's the only way.
And a real low noise,
noise floor.
Within that chamber.
Exactly.
And that's something NRC has, and because you got to get down below 1% or something like that. And even though our distortion measurement is rather crude and it shows total harmonic distortion, it doesn't break it down. We've changed the designs of, I would say, a dozen companies when it's come in and it's shown distortion that they had no idea was there. And then, thankfully, most of these companies go back and change their designs.
Right.
And the next version of those loudspeakers improves upon that. Mm-hmm. So it is that. And I'll tell you something really interesting. There's another person I'll bring into this. When we announced in about 2000 that we'd be publishing measurements, John Ottvoss, I don't know if you remember him, from Waveform,
right.
Big believer in measurements, part of the NRC history, that sort of thing, said, that is great. You're going to publish measurements and you are going to be out of business in 6 months. And I said, what? And he said, because all these companies aren't going to want to have you measuring their speakers. And I said, oh. And it's true, not the out of business. A couple companies refuse to send us their speakers.
Interesting.
A couple.
Right.
The vast majority, Axiom, speakers from PSB, speakers from API, where you were at the time, welcome somebody actually producing credible measurements.
Right.
And suddenly we had people sending us speakers that never would have maybe before, or wouldn't in those numbers before, and that sort of thing. So it really helped us.
Right. So in this suite of measurements that you do at the NRC, Doug, or you have somebody do for you, so for your readers that click through that link in your reviews and actually go to the measurements, what do you suggest that they look out for, or in fact, what do you look out for? What are you searching for in those measurements that maybe suggest that, well, this is a really well-designed loudspeaker and this is why, or this speaker might have a problem because of this, and also, do you find, measurements don't tell the truth. We know that.
Or the whole story.
Well, they tell the truth, that's exactly correct, but, we still have to listen to them, and that really is the final arbiter of, of how a speaker performs, is listening to it. But, the measurements are a tool, and they can be flawed. There are some, things that you can be either fooled by, or limitations of your suite of measurements or any suite of measurements. I'd like your input on those things.
Yeah, one thing, I do believe we're doing some of the best speaker measurements of all the magazines, but they're a limited set of measurements. And part of that has to do with cost. As we said in the previous video, it costs us money to measure at NRC. We pay it on a time basis, and a lot. And so right off the bat, we said we're going to do a limited suite of measurements that is going to more give us an indication of performance, corroborate claims, but won't necessarily go beyond that. And I could ask you maybe what you think about what we do and go beyond that if we're on the same path. At the same time, before we started the measurements, I talked to a lot of designers, and I probably talked to you, Ian, at Axiom about this, was should we interpret them and write up a thing about interpreting? And I got the warning of do not try to interpret sound out of those measurements, even though you've got really good ones, because it's not the full picture. And I believe that's a deficiency in some publications where they do a very limited number of measurements and then try to interpret too much from the measurements. Right. You can interpret some things, but you can't interpret entirely what it's going to sound like. You've got to go far beyond. We do to 75 degrees off axis horizontally. We don't do a sound power, which maybe you can explain what a sound power is.
Yeah, sound power basically is you measure 360 degrees around the loudspeaker in its normal position, and then you flip it on its side and you do the same 360 degrees. So you essentially create an entire sphere of all the radiated energy, you know, below, behind, everywhere around the speaker cabinet, and you do some complex averaging and mathematics to then give you what's known as the sound power curve. But, you know, it's, in our case at Axiom, when we measure a sound power, that's 96 response sweeps. And it takes, a couple of hours probably to accurately do that and then actually write down and notate everything. So doesn't surprise me at all. I mean, that would cost you a lot of money. And you know what? You do a listening window.
Yes.
And that's a real good indicator of how a company is, you know, cares about dispersion and radiation pattern of the speaker. And if the listening window is a mess, you can pretty much guarantee that the sound power is going to be a mess too. And
I 100% agree with that. So what I would say you can glean from our measurements, we do on axis out to 75 degrees off axis in 15-degree increments, and then 15 degrees above and below. And then that 15 on either side, above and below, average with the center, gives that listening window.
Right.
And from those 75 degrees and the listening window, you can get an idea of what it's going to sound like and also show up some real problems or anomalies. If you don't have a smooth off-axis dispersion to there, it's not going to improve going at 360 degrees. You can see if the company cares about dispersion on their speakers. You can kind of get the general how neutral it is across the frequency band. What I warn people, and there's magazines who just produce, they think, oh, well, we'll just produce an on-axis measurement, right? Just one measurement in front. I wouldn't say that's 100% useless, but it's not very useful.
It's pretty, right? It's actually, I'll argue with you there, it's pretty useless.
It's pretty useless.
I would actually rather a magazine or publication not do any measurements and just sit and listen, give us our subjective opinion than that one curve, because it really, people still believe that we're in the 50s and the 60s, where that was maybe an accolade that we were going for flatness on axis, and that's all that mattered. And it's shocking the number. I have to educate a number of customers or potential customers. They'll call and say, I was looking at your measurements and blah, blah, blah. And, you know, some people said those speakers are much flatter than yours are. I'm like, well, that one measurement doesn't tell the story. It really doesn't at all, in my opinion.
It could mislead as well.
And the reason why is it doesn't, those off-axis measurements really tell you how the speaker is going to interact with the room.
Yeah.
And that was a lot of the NRC's research with Floyd Toole, discovering that off-axis is important, is very important. So.
Yeah, and that's why, I would agree. The one, because it can be tremendously misleading to see that. Even if it's perfectly flat, it could be going 15 degrees off, right? You know what I mean? Really, really poor. But I would say that's why we don't just do the listening window. If we just did the listening window, that would be more than the other magazines, and that would tell you something. But at least 75 degrees, you're getting, okay, what's really going wrong or right.
Yeah, and if you're good out to 75 degrees, like you said, I'm going to probably bet that you're probably good all the way around, and that you probably have a reasonably decent sound power at that point, at least the horizontal perspective.
Yeah. I would say that's really important to look at those measurements out to 75 degrees and understand what the dispersion means. I would say the sensitivity is relatively important to look at, because that'll tell you a bit about how much amplifier power you need. And we publish that based on the listening window. Oftentimes our sensitivity might be a dB under an accurate manufacturer spec, because we average the listening window to create that sensitivity over 300 to 3K. 300 hertz to 3K. So if you just use your on axis and do a limited thing, you might be able to nudge it higher, but it'll give you. And then also I'd say impedance is fairly important to look at, providing we have had speakers that dip to half an ohm, right? Which will destroy most amplifiers or trip their protection circuitry, even on good ones. So that's important to look at. What's probably least important to look at in our measurements is to take too much credibility in the bass measurement. And this is something we want to improve, actually. If not this year, find a way to... The chamber is only good down to, when I say good, uncalibrated down to 120, 150 hertz. And then it starts getting inaccurate because of the size of the wavelengths, and it's trying to capture it. There is a correction put in, but it's not 100% accurate. And we don't try to sum in the port response, like what's on the back of the speaker. So you'll see some wonky things happening in our bass, which are there, but it's just not a full characterization of what the bass. Would you agree with that? A characterization?
Yeah. I mean, this is, I think, something that many people don't understand is that in an anechoic chamber, it's only anechoic, i.e. it has no echo, no reflections down to a certain frequency. And that's based on both the overall dimensions of the interior of the chamber and the size of the acoustic wedges that are in there. Now, you might say, well, why not just build a bigger chamber? It's an exponential problem. So to get, let's say we cared about 20 hertz, typical 20 to 20,000. If we can measure that accurately, that would be great. Well, our chamber is certified down to 80 hertz, and it's the same as the NRC, and it's pretty huge. So if you wanted to go down to 20 hertz, you could probably drive a transport truck into a chamber that size. And they do exist, but I mean, you'd be talking millions and millions of dollars.
And Health Canada's got a chamber that I think is 6 times the size of NRC's, but it's only good to 50 hertz.
Yeah, so that gives you a good example. And they actually have used that, I think, they drive school buses and things in to do measurements.
But you do a bass, you actually measure bass outside on a pole.
Yeah, correct? Yeah. So we want to, you can calibrate a chamber to get over the fact that it's not truly anechoic at those low frequencies, below 80 hertz in the case of the NRC chamber and our chamber. So how would you do the calibration? How do you know what's going on down to 20 hertz or 10 hertz? Well, you can still make a speaker anechoic if you get it in the outside air and away from the ground so that there's no boundaries around it. We actually have a 100-foot high tower that we'll actually put the loudspeaker on. Every model we have at Axiom we'll put on that tower and do a measurement of it, and then we'll create a correction curve so that we can now place that same speaker in our chamber and have an accurate, truly anechoic measurement. It's important because things like, and you've probably run into this, a tall floor standing speaker like this, where you've got distributed woofers, so you've got 2, 3, 4, however many woofers. They're all in different locations relative to where the mic is pointing, and they all interact differently with the chamber because those low frequencies are, it's not anechoic. So it's very important because without that correction curve, the speaker is just not going to be accurate at bass frequencies, even though you have the luxury of an anechoic chamber to measure it.
And I will say, about I've traveled to a lot of companies around the world. Maybe somebody has a 100-foot pole, but I've never seen one other than at Axiom.
Fascinating stuff. And again, I thank from all loudspeaker companies out there. I mean, maybe some of them are sending you products because they get a little free R&D out of it from this measurement suite. Yeah. But anyway, it's a great thing. We applaud it and keep it up.
Yeah, no, I think it's really important.
All right. Thanks, Doug. Okay. Thanks for watching, everyone.